When you think about online stores, app subscriptions, or any type of transaction that takes place online, how do providers simplify the payment process for their international consumers? You might answer that consumers can make payments using their local currency. The conversion is already done for them. But how? Functional programming can help you manipulate data more effectively. And over the next few minutes, you'll learn what it is and discover how to write your own higher order functions. Let's take Little Lemon as an example. Suppose that not all their customers are local to the area, and because of this, customers use different currencies when making payments through the app. This means that the Little Lemon app must convert the menu prices from the base currency to the currency that the users have selected. The underlying code must be reusable to ensure the functionality carries through to various places in the application. Functional programming is one of the ways to do this. Functional programming is a concept that helps you pass functions to other functions as arguments, return a function as an argument, or assign a function to a variable. A higher order function describes a function that can at least satisfy one condition by either taking one or more functions as an argument or returning a function as its result. Swift supports functional programming and higher order functions through closures. Closures enable the passing of functions as arguments and store them in local variables. Using this method can enable you to implement different requirements in your application in a more convenient way. An example of functional programming would be storing a closure in a variable or constant. And a function becomes a higher order function when you declare one of its arguments as a closure. To summarize, functional programming in Swift describes the process of using closures to pass functionality to other functions, while a higher order function is a function that takes or returns closures. To put this into context, let's revisit the currency conversion scenario. Suppose the price needs to be multiplied by 2. First, let's explore how the currency conversion code works without functional programming applied. You would first create an array of integer values and assign it to a variable. The values inside the array represent the cost of certain meals. Then, to convert the prices from the base currency to another currency, you would use a for-in loop that iterates over all the prices, multiplies each value by 2, and modifies the original array with updated values. Now, let's explore the functional way of implementing the same logic by using a higher order function. To begin, let's define an array for the original menu prices. I declare a constant called original prices and initialize it with an array of numbers. For the sake of the example, let's keep all of them whole integer numbers. Next, I'll demonstrate how to write a higher order function to transform the price list using a given closure and then return the new list as a result. To declare the function, I insert the keyword func followed by convert prices as its name. Then I pass in the first argument original prices as an array of integers. For the second argument, I define a closure called conversion closure with a price parameter of type integer and set the return to return the updated price of type integer. The function itself is defined to return a new array of updated prices. Next, to implement the function, I declare an array of integers as a local variable called converted prices that will hold the final result. Then I define a for-in loop to go over each of the elements of the original prices array that the function receives. Inside the for-in loop, I declare a constant to hold a converted result of the original price. I call it converted price and initialize it with the closure call that takes original price as its argument. Next, I append each of the converted elements to the converted prices array. And finally, To complete the function, I returned the resulting converted prices array. Now that the initial array and higher order function are defined, let's explore an example of how it can be implemented to multiply the original prices by 2. I call the higher order function and set the first argument as the originally defined array of prices. Then for the second argument, I set a closure that multiplies each price it gets by 2. I run the code and observe that all the prices have doubled. Now the function can be reused several times to produce different results by changing the closure. In this video, you've learned how functional programming allows you to pass functions as arguments and assign them to variables. You've also learned that functions that return or take a function as an argument are called higher order functions. In addition to this, you also discovered how to write your own higher order function to transform data and make it reusable. Functional programming and higher order functions in Swift use closures to optimize your code reusability.